Hi there. Thanks for joining us yet again on Space Nuts. This is a Q&A episode where we answer your questions. You ask the questions, we, as in the royal we, as in Fred, answers them. We should do it the other way around one day. We ask you the questions. Why don't you get a job for a starter? But anyway, coming up on this episode, we're going to answer questions about protecting the moon, the sound of liquids on other worlds. Interesting. Dark matter movement. Oh, shocker. Dark matter question. And how atmospheres are formed. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
One man who's got a job is Professor Fred Watson, astronomer at large. Unlike me, I don't work anymore. I've chucked it all in. This is not a job. This is fun. This is a hobby. Hi, Fred.
Yeah, it's fun for me. Excuse me, it's fun for me too. But you're right, I do have a job, and
Yes.
there we go.
Yes. Now, we have got a lot to get through, so I think we'll just plough straight into it. And our first question comes from a regular sender-innerer. His name is Mikey.
Hey, Fred and Andrew. It's Mikey once again from Way Too Hot, Illinois. Got a question for you guys. I know we have like a planetary protection for incoming asteroids that threaten Earth, but do we have the same thing for the moon? Like, what if a ginormous asteroid were to hit the moon and blow it to smithereens or knock it off course or alter it in some huge way? Because the moon is very important to the life on Earth, right? So I guess, first of all, what would happen if something happened to the moon? Would we still have a good chance of surviving? And secondly, is there a protection plan in place like there is for the Earth for the moon? Thanks, guys. Love the podcast.
Thanks, Mikey. Always asks interesting questions. The answer is no and yes.
Well, it is, yeah.
Yeah. We've had questions about the loss of the moon before and what might happen to us, and I do believe that we have discussed maybe once or twice that the protection of the planet includes the moon. We realise that we can't just protect ourselves. We've got to protect the moon. Otherwise, if it gets obliterated, we're in big trouble.
Yeah, okay. So,
but getting obliterated, that would have to be a huge object.
that's the point. There's nothing. There's no scenario that we can envisage at the moment that would involve such a collision. So we're talking about asteroids. Even something measured in kilometers hitting the moon would be of concern to us because the moon's very close to the Earth, and that's one of the things that we need to know about. So the bottom line is that our protection of Earth, in terms of it's not actually planetary protection, is something slightly different. That's a biological thing. Planetary defense is what we're talking about, and defending the Earth effectively means we defend the moon as well, in the sense that if we are looking for hazardous objects, and that's a well-established technology, which we're doing. We think we've discovered most of the objects that might threaten Earth and the moon, which are more than a kilometre in size. It's the objects of a few hundred metres that we're looking at now. Now, the detection of those is part and parcel of modern astronomy, and we find them with regularity. If one was on a collision course with the Earth, then we'd do something about it, and we've discussed that before many times, Andrew. If
We've
one of these,
the theory of deflection.
yes, indeed, with the DART mission, that's right. But if one of them was shown to impact the moon, we wouldn't do anything about it. I think we would let it happen because it's just part of the natural cycle of events. And unless there was a threat to humans on the moon, you wouldn't do anything about it. And in fact, if you knew enough about such an object going to hit the moon, you'd bring your humans back. You'd get them off the moon. because that's a lot easier than trying to deflect an asteroid. It's lunar defense is basically wrapped up within planetary defense of the Earth, with the one exception that we would not try and deflect an asteroid if one of any particular size was shown to be targeting the moon.
It gets hit a lot anyway, doesn't it?
It does. That's right. Yeah, it's getting and because there's no atmosphere on the moon, they get clouted. The moon gets clouted much more forcefully than the Earth does by these incoming objects. So yes, it's a work in progress. It's happening all the time, sometimes there's interesting physics involved. If you can see the flash of an impacting meteor or asteroid, then you've got new data to look at and to work with.
If something was big enough to destroy the moon, we probably wouldn't have a prayer of stopping it anyway, would we?
No, we wouldn't, and there isn't anything, so it's okay.
No. Yeah, well, not within our solar system, but maybe something.
Yeah, that's right.
Extra solar might come through. We've had a couple of those over the years.
Yeah, the thing is, the bigger the object is, the easier it is to detect, and there's just nothing on the horizon, even of that kind at the moment.
Although the moon, being made of cheese, would absorb an impact quite easily.
Unless it was a particularly hard cheddar, that might sort of,
Yes, well, that's a point. Yeah. Yes. All right. I can think of a few cheese puns, but let's move on. Thanks, Mikey. Good to hear from you. Our next question comes from somebody else, and I've actually managed to lose it. Here we go. Don't know how that happened. Thank you, Windows. G'day, Fred and Andrew. As a native Minnesotan. All right, Minnesotan. I quite enjoy taking holiday time along the north shore of Lake Superior. I love the sound of the waves washing onto the shore, and that got me to thinking about lakes and rivers on Titan. Would they sound comparable to what we have on Earth? Or, because it's not water, would there be some kind of distinctive difference to the sound of the liquid ethane, methane interacting with its surroundings? I realise this is probably out of Fred's area of expertise, but that's par for the course here on Space Nuts. Thanks very much, guys, from James Greenfield. James asks an interesting question, because we've talked in the past about different types of suns, and if life existed on worlds surrounding those suns, the trees might have different coloured leaves and things like that. But I would imagine also that sounds on other planets and other moons would vary depending on the conditions, would they not?
Yes, they would, and there's two things at play here. First of all, there's the liquid, which may be quite viscous. We don't really know. It's sort of oily. It's hydrocarbon. We know what liquid hydrocarbons are like here on Earth, but there might be, compounds within it that make it a bit more viscous. We think we covered a story not long ago that suggested that if you look at the shape of the lakes on Titan, you can tell that there are waves there, wind-blown waves.
Yeah, that's right.
But the likelihood is they're not very high, because radar reflections from Titan's seas are very, very smooth indeed. And so, I've read some papers that suggest that the waves are only millimeters high, which probably wouldn't make much noise. The other thing, though, that is the atmosphere, which is at a different pressure from our atmosphere on planet Earth. 1.5 bars is the atmospheric pressure there, so it basically is 50% higher than our atmospheric pressure here. So that's going to change the speed of sound. It's going to change the way things sound. It's really hard to imagine what the waves on Titan might sound like. And I think James poses a really interesting question.
There'd probably be a way of working it out, though, if you really needed to know that.
There will be, and
because-
somebody will do a simulation if needed. But theory would help as well.
It would also change the pitch of your voice, wouldn't it?
Yeah, that's right. Probably. Yeah. Hello, Andrew, joining you.
Yeah, well, you'd probably be going, help, and that'd be the end of that.
That'd be the end of that. That's right, yeah.
But, everything would probably be different in one way or another. So, yeah, definitely, James, you would have a different sounding liquid scenario on somewhere like Titan and any other place with liquid surfaces. Good to get your question. Thank you, James. This is Space Nuts. Andrew Dunkley with Professor Fred Watson. Let's take a quick break from the show to tell you about our sponsor, NordVPN. And a virtual private network is something that a lot of people use these days to protect what they're doing online from scammers and hackers and anybody else who wants to download your information and sell it on the dark web, which has become all too common. Of course, identity theft is another big reason that people get hacked, and it just goes on and on and on. So how do you protect yourself? Well, the first line of defense is a virtual private network, and there is none better than our sponsor, NordVPN. And as a Space Nuts listener, there's an exclusive and special deal for you, including a 30-day money-back guarantee and an extra 4 months just for signing up. That's 4 months extra for a 2-year deal, or you can go month by month. So all you have to do is go to the URL that's been set up for you, nordvpn.com/spacenuts. That'll bring you to an introduction page where you can click on a button that says Get the Deal. And once you're in there, you can look at all the products that are available, not just the virtual private network, but the other products, depending on what level you want to go. Now, if you want to stick to the basic service, that's fine. You can get high-speed VPN, and you can secure 10 devices at once. 10. So they've upped the ante on that. And you can then increase what you consider to be useful to you under the different packages that are available. I've got everything. My favourite of all is the cross-platform password manager. This is a really great product, and I've talked about it many times. But, you can find out more at this URL, nordvpn.com/spacenuts. Check out their prices, check out their packages, check out what you need, and go accordingly, because the longer you sign up for, the lower the price gets on a monthly basis. But, very much worthwhile, and an extra 4 months. So a great deal for Space Nuts listeners. nordvpn.com/spacenuts. Have a look today and get the deal. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
To our next question, an audio question. This one, Fred, comes from Bill.
Hi, this is Bill, San Francisco Bay Area. My question is, could dark matter travel through space? So dark matter apparently doesn't interact with other things other than through gravity. So could dark matter get thrown around or out of a galaxy due to other gravitational events, kind of like planets and other stuff does? That's my question. Love the show. Thanks.
Thank you, Bill. Bill's from a very watery part of the world as well, San Francisco Bay. It would have some sloshy sounds around it. Indeed. Dark matter, we did talk about it recently in light of the fact that they discovered that it may well interact with itself, but that's not what he's asking. He's asking about dark matter movement. Can it move around? We also, I think, discussed that it seems to concentrate around galaxies and in places of saturation, I suppose, of other objects. So, yeah, it's an interesting question.
That's right. So dark matter basically is where normal matter is. And we think that's no accident. We think that the dark matter cosmic web provided basically gravitational centers for normal matter to collect and turn into stars and galaxies. But you've highlighted one of the crucial aspects of this that we did talk a couple of weeks ago, I think it was, about the idea that dark matter might interact with itself, some evidence that seemed to suggest that. Although I think the common view is still that it doesn't. And and the evidence for that comes from something that directly answers Bill's question. Can dark matter move? And the answer is yes. There is, and if I remember rightly, I think it's called the Pandora cluster. It's a cluster of galaxies, which is actually two galaxy clusters colliding. And what you can see there is the material of the galaxies themselves, the gas and dust that we can see, sort of piles up in this collision. And so you've got a galaxy cluster that's made up of two galaxy clusters in the act of colliding. But the dark matter, which is around them, and we can detect that by means of gravitational lensing, the dark matter just carries on. So what you've got is this galaxy cluster. It's two galaxies that have collided and they've wound up together. But then on either side of them, on each side is a blob of dark matter. The dark matter has passed through itself. The two dark matter halos of each of the two clusters has gone through itself and not interacted. And that's why people think dark matter does not interact with itself. But it does prove the answer to Bill's question that dark matter can move.
It can move. Okay. We don't know a lot about it, Bill, and we're trying to find out what we can. There's studies into it, but it's elusive because it's dark matter. It
doesn't interact.
It's not of our realm, technically speaking, does it? Yeah.
That's a nice way to put it. It is not of our realm. That's right.
Yeah. Thank you, Bill. Great to hear from you too. And our final question today comes from Brady. Hello from the great state of Florida. I have a question, Fred. Why does everyone who lives in Florida call it the great state of Florida? Most of the questions we get say, hey, I'm from the great state of Florida. Are they just saying Florida abbreviated? Is it actually called the great state of Florida? I'm being a bit coy here.
I think it's local pride.
I think it is too.
I think we get it from other states as well. Everybody's, happy about where they live, which is great.
Well, I can get it. I mean, they've got 50 states to sort of talk about. We've only got half a dozen. But we're one country. Split into states, but during the football season, New South Wales and Queensland hate each other. So it's just a temporary thing.
Yes.
Other than that, we're really good friends. Yeah. So from the great state of Florida, Brady asks, I was wondering how atmospheres are formed. How do they go from a ball of rock and lava to having an atmosphere? Good question. Yeah, I have never pondered that, and I'm glad you asked.
It is a good question. So, if you've got a world at the temperature at which the volatile material, the stuff that easily turns into gas, is gas, then you're going to have a gas envelope around a planet. It's a great question. And when you think of the way planets are formed, they start off as dust and gas. And so you've got this kind of bedding down process where the dust turns into planetesimals and they all bash into each other, and that probably heats up everything so that the temperature exceeds where things like nitrogen and oxygen and carbon dioxide are gas. Then what you end up with is a solid world, because the other things, the silicates and things like that, are at temperatures that are solid, within the places like the Goldilocks zone, and so you end up with this natural scenario of a solid rocky body with a gas envelope. And that's turned on its head when we get out to the giant planets, because the rocky body there is very small and probably has quite a lot of water ice in it, because you're beyond the frost line. And the gas is the main part of the body. So the atmosphere of a gas giant is formed in a rather different way from the atmosphere of a rocky planet. Yeah,
in fact, gas giants are very different, because you're basically looking at, depending on the size, but you're getting on towards star formation. Some of those gas giants are actually failed stars, aren't they?
Effectively, yeah. Jupiter's often described as a failed star. It would have to be about 90 times bigger, I think, if I remember rightly, to be a star. If it was only 13 times bigger, though, it would be a brown dwarf star, which is a different kind of category of star. But yeah.
Yeah. So it's got a lot to do with proximity to the star, Goldilocks zone. All those things come into play. Although you get gas giants that are close to their parent star too, which is seemingly so far fairly normal in the discovery of exoplanets.
Yeah, and you get them a long way from planets as well. A long way from their stars, like the planets, the gas giants in the solar system.
Okay, so it's just part of a process.
Yes, I think that's the way to put it. Thank you, Brady. You've kind of highlighted my thinking about these planets and their atmospheres, and it is a process. That's the way to put it.
Yes. All right. Good question, Brady. Look, I don't think it'll happen, but one day someone might send a question in where I go, that's just not interesting, and it's a bad question.
No, it
hasn't happened yet.
No,
hasn't happened yet.
It's not going to happen, Andrew. It's all right.
No, definitely not. But if you do have questions for us, go to our website, because that's where you send them through. AMA is the little tab at the top, and when you click on that, it tells you to go away. But if you don't want to go away, you can put your name, your email address, and your message into the system and send us a text question, or you can press the start recording button and it will record your question using your voice. And don't forget to tell us who you are and where you're from. And if you're a follower of Space Nuts on social media, don't forget to like us, follow us, join us, or hit the subscribe button, depending on the platform that you prefer. We're all done. Fred, thank you very much again.
It's a pleasure. I'm always happy to be on Space Nuts. Thank you, Andrew.
Oh, I'm glad you are. Otherwise, you probably would have left 8 years ago.
Yeah.
Professor Fred Watson, astronomer at large, and thanks to Hugh in the studio, who's busily making lunch, I think. Yeah, I can't see him. He's not on the camera. No. It's a brush turkey sandwich by the look of it. Good on you. And from me, Andrew Dunkley, thanks for your company as always. Catch you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.